This is problem 3.3.40. Let's see, so it tells us that our price P in dollars and our number of sales, X, on a certain item follow this equation. So 5P plus 4X plus 3PX equals 101. Suppose that also that P and X are both functions of time. Now that functions of time, that's telling you that P and X are both kind of related to time, which makes sense that like price and number of sales would be related to time. Okay. But you notice that there's no T variable up here in our equation. And that right away kind of keys me into the fact that this is going to be a related rates problem. That they're both related to this third variable that we're not actually seeing. And then it says find the rate at which X is changing. So find the rate when X is changing, that means find how fast is X changing. So in this case it would be dx dt. We know that the T should go on the bottom because it says X is a function of time. So X is a function of time, so X goes on top, T goes on bottom. It tells us X is 4, P is 5, and P is changing with respect to time at a rate of 1.3. Okay, so we start off with this equation, 5P plus 4X plus 3PX equals 101. And anytime we're looking for a rate or change or anything like that, that means find the derivative. But P and X are both related to T. So when I find these derivatives, I have to make sure I'm using implicit differentiation. So like if I take the derivative of P, I have to tack on or multiply by dp dt. And if I take the derivative of X, I'll need to times it by dx dt. So let's go through. And at this point, you do the derivative exactly as normal, except for, again, we're going to tack on those dp dt or dx dt. So the derivative of 5p would normally be 5 times the derivative of p is 1. But because p is some function of t and we don't really know what, we're going to kind of do that like hidden chain rule and say, and then we'll have to times it by the derivative of the inside, which is some function of t. We don't know what, so we just say dp dt. Plus, now the derivative of 4x, we'll do 4. The derivative of x would normally be 1. And then we need to tack on dx dt, because x is really some function of t, so we need to have that inside derivative. Plus, now here's what makes this problem difficult. This piece right here, we need to use a product rule, because we have a p and an x. Okay. So to do this product rule, the product rule says if you have the derivative of f times g is going to be f times g prime plus g times f prime. Ignore my d over dx because we're not really differentiating between x's and p's at the moment. That's just what our formula usually looks like. Okay, so we'll divide this up into first and last. So put the first piece in like normal, and then take the derivative of the second piece. So derivative of x is 1, but you have to times it by dx dt anytime you take the derivative of x. Plus, and then put the second part in as it is, so x times the derivative of the first part, 3p would just be 3 times 1, but you have to tack on dp dt. And so that was what we got when we did the product rule in the middle of our problem. And the derivative of 101 is just 0. Now we've done all that. Now we can go ahead and plug in the things they tell us. So now we'll plug in x equals 4, p equals 5, dp dt equals 1.3, and we'll find dx dt. Okay, let's see, so 5 times 1, that just simplifies. 5 dp dt is 1.3 plus 4 times dx dt, which I don't know yet, that's what I'm looking for, plus 3 times p, which is 5, times dx dt, plus x, which is 4, times 3 times dp dt, which is 1.3, equals 0. So I went ahead and put all in my calculator, so I get 6.5 plus 4 dx dt plus 15 dx dt plus 15.6 equals 0. So let's put the dx dt's together. So we'll get 19 dx dt, and we'll move the 6.5 and the 15.6 the other side by subtracting. So we'll get negative 22.1, and we can divide both sides by 19. So negative 1.16. So this tells us when all those conditions are met. So when x was 4, when p was 5, when p is changing every 1.3, then we can tell you that the x, or the number of items we're selling, is dropping at a rate of 1.16 units of time. Whether that was minutes or days or hours, it didn't actually tell us.